All right, so this is the demonstration of the in-class example. I already covered, so maybe when you see this one, I already covered this in-class example, but I wanted to double check you already understood this one, or maybe you can use it for your future reference or some repeated practice for that. You already have the answer key, but maybe you can try to do it by yourself. All right, so this is equation, and x underscore I means the nth score of the x. Also, the y underscore I is the nth y. So this is just the sum of the x minus the x bar, which is the mean of the x, and y minus y bar, which is also the mean of the y. So let me just calculate the average. So average of the age variable, and we can just drag it, right? Very easy, right? Okay, and also average or mean of the y. And then you can calculate that. So you can just simply calculate it, but maybe we can go further because the step number one is null hypothesis and alternative hypothesis. So we would say the null hypothesis is that there is no association or there is no correlation, or the age and education is independent, or the relationship between the age and education is nothing, or they are not correlated. So you can use any language or any word, but you can just say that there is no relationship in the null hypothesis. And alternative hypothesis means that there is anyway there is some correlation between age and education. So this is the step number one. And step number two is finding the critical area. You may remember that the degrees of freedom can be counted as the paired sample size minus 1. And you can see this paired sample size is 15, but in the more scientific way, you can use the count. Okay, open the parenthesis, and the number of cases, close the parenthesis, minus 2. So that will be 13. You can go to the Pearson's R table on the Moodle, but I already added the link, so maybe you can just click, then your web browser will see this one. So you might remember that the degrees of freedom is 13, and we are usually, and every time actually we use the degrees of freedom, no, alpha level as 0.05. No, not this one, 0.05. So you can use 0.05, and then the degrees of freedom was 13, right? Oh, so there is some so our the R critical is 13 and 0.5, so that will be 0.514. 0.514. So we can find the critical is 0.514, which is our R critical. So actually we can just compare R calculated and R critical later. So if R calculated is bigger than R critical, I mean the absolute value of the R calculated is bigger than R critical, we can reject the null. But otherwise, we fail to reject the null. Okay, so we already know the R critical, so maybe we can calculate others as well. So x1 minus x bar. So x1 is here, and x bar, you can simply type 30.53 as the number of the mean, but if you want to just click and use the handle, you can just put this number, and if your keyboard has the function key as the function 4, you can use the function key as F4. So $C $18, which is the fixing the address of the mean, and then you can just drag it like this. Or if you are not familiar with that, just use the number in the second decimal, so 30.53. Okay, then yeah, you will generate the same number. All right, And also y1 minus y bar, that's also the first y minus the mean of the y, that is 14.13, right? And then just drag it. Alright, so we already have that x1 minus x bar, which is the distance between each case and the mean, and the y1 minus y bar, which is the distance between the y and the mean of the y. So this is the multiplication of those two sections. So multiply this one as well. Alright, and just drag it so that you can add everything, right? So let's leave the sum just now without something. Alright, so this one, x minus x1 minus xi, or xi minus x bar, just hat 2 is the square, right? And also just drag it now by, and then alright, this number yi minus y bar and hat 2. Alright, so just drag it. Alright, so the sum, because the numerator is the sum of the xi minus x bar multiplied by the yi minus y bar. The sum, so numerator can be calculated as equal sum and those numbers. Alright, so actually the it's also this one multiply this one, so sum, so you need to find the sum of this number and sum of this number as well, so just drag it. Alright, now we can calculate the numbers here. So why don't we find the numerator first? So this is the sum of the xi minus x bar and y minus y bar. So that is we already calculated here, right? So this is already here. And denominator, so that is actually the square root of this the multiplication of those two numbers. So sqrt, open the parenthesis, and this one as the first part here multiplied by second part here. It means that we need to go here. Okay. Alright. So we calculate it. So yeah, correlation coefficient R is, oh no, maybe it perceived as some brand name. So correlation coefficient R is the numerator divided the denominator here. So that is numerator divided by denominator. Alright, so this is around 0.72. So we would say that our calculated R, I mean the absolute value of the calculated R, is bigger than R critical. So the conclusion will be reject the null. And then the size of correlation, we can see 0.72 belongs to this category. So we would say high, and this is positive number, so high positive correlation. And also the R square is just squaring the R, the determination, the coefficient of the determination. So you can say that if you multiply 100 to the R square, that will be 51. So 51% of the variability in education, years of education, can be predicted by the independent variable, or X, by the age. So this is the format. So we will discover the step number 1, checking the null and alternative hypothesis. The step number 2 is the R, finding the R critical. So based on the table, I mean the Pearson's R table, we found the R critical based on the degrees of freedom and the R per level. And we also calculated the numerator and the denominator here, correlation coefficient R, and based on the calculated coefficient R and comparing the absolute value of the calculated R and compared with R critical, our calculated R is bigger than the R critical, so we reject the null. And then reject the null means there is correlation anyway, the statistically significant correlation between those two variables. And based on the value and the size of the R, we can see there is the highly positive, and also the sign of the R is positive number. So this is also the positive relationship. So we can say that there is a high positive correlation. And after squaring the R, we found that 0.51 is R squared. And this is it means that 51% of variability in education can be predicted by age. All right, so this is the whole format of the explanation or calculation process of the correlation. You can review it later for your the future assignment or your future assignment, because you will use SPSS for your final paper. All right, so let me know if you have other questions via email.